हेलो फ्रेंड्स, कैसे हैं आप सभी। आशा है आप सभी स्वस्थ होंगे और स्वस्थ रह करके अपने नीट एग्जामिनेशन की तैयारियों में जी जान से जुटे होंगे। इस वीडियो लिंक में हम लोग इलेक्ट्रिक पोटेंशियल ड्यू टू ए कंटिन्यूअस चार्ज डिस्ट्रीब्यूशन टॉपिक पे स्टडी करेंगे। इलेक्ट्रिक पोटेंशियल ड्यू टू ए कंटिन्यूअस due to a continuous charge distribution. We can imagine that a continuous charge distribution consists of a number of small charge element. We can imagine that a continuous charge distribution, that a continuous charge distribution consists of a number of small charge, consists of a number of small charge element located at position, elements located at position. Ri vector. Ri vector. If R is the position vector of point P, if R vector is the position of point P, then electric potential at point P, then electric potential at point P due to continuous charge distribution, due to continuous charge distribution can be written as V equal 1 upon 4 pi epsilon naught integral dq mod r minus ri cap. When the charge is distributed continuously, when the charge is distributed continuously in a volume V, in a volume V, dq equal to rho dV, dq equal to rho dV, where rho is volume charge density, where rho is the volume charge density. The potential at point P due to the potential at point P due to volume charge distribution will be volume charge distribution will be V equal 1 upon 4 pi epsilon naught integral rho dv upon r mod r vector minus ri vector. When the charge is distributed continuously over an area, when the charge is distributed continuously over an area yes, then dq equal to sigma ds, where sigma is the surface charge density, where sigma is the surface charge density, then Vs equal to 1 upon 4 pi epsilon naught integral sigma ds upon mod r minus r I वेक्टर का कैप हो जाएगा. When the charge is distributed uniformly along a line, when the charge is distributed along a line L, then dq equal to lambda dl, and then vl equal to 1 upon 4 pi epsilon naught integral lambda dl upon mod r minus ri वेक्टर का कैप हो जाएगा. The net potential at the point P due to continuous charge distribution, the net potential at the point P due to continuous charge distribution will be continuous charge distribution will be V continuous equal to Vv plus Vs plus Vl, that is 1 upon 4 pi epsilon naught integral rho dv upon mod r vector minus ri vector mod plus sigma ds mod r vector minus ri vector plus lambda dl r vector minus ri का cap. Now we will see electric potential due to a general source. Electric potential due to a general source. potential due to a general source. The potential due to a general source charge distribution, the potential due to a general source charge distribution, which consists of continuous as well as continuous as well as discrete point charges will be V equal to V continuous plus V discrete. That is V equal 1 upon 4 pi epsilon naught, and integral V rho dV upon mod R vector minus Ri vector plus integral S sigma ds upon vector Ri minus Ri का कैप प्लस इंटीग्रल L लो लैम्डा dl upon mod R minus Ri का कैप प्लस summation of all point charges, that is qi upon mod R vector minus Ri vector. Now friends, we will describe about electric potential due to a electric potential due to a uniformly charged thin spherical cell. Uniformly charged thin spherical cell. Consider a uniformly charged spherical cell. Consider a uniformly charged spherical cell of radius capital R and carrying charge Q and carrying charge Q. We wish to calculate its potential. We calculate its potential at point P at distance R. At point P at distance R from its center O. There are three situations for calculating the potential. Number first, when the point P lies outside the cell. Number first, when the point P lies outside of the cell. We know that for a uniformly charged spherical cell, we know that a uniformly charged spherical cell, the electric field outside of the cell, spherical cell, the electric field outside of the cell is as if the entire charge is concentrated, as if the entire charge is concentrated at the center. Hence, electric potential and outside electric potential at outside point P is equal to that of a point charge located at a point charge located at the center, which is given by V equal 1 upon 4 pi epsilon naught small q upon r, small q upon small r for small r is greater than capital R. Number second point, when the point P lies on the surface of the cell, when the point P lies on the surface of the cell, then V equal 1 upon 4 pi epsilon naught q upon capital R. Number third, here small r equal to capital R. Third point, when point P lies inside the cell, when point P lies inside the cell where r is less than capital R, then V equal 1 upon 4 pi epsilon naught q upon capital R. सो फ्रेंड्स, इस वीडियो लिंक में इतना ही। अगले वीडियो लिंक में हम लोग जो है रिलेशन बिटवीन इलेक्ट्रिक फील्ड एंड पोटेंशियल, यानी कि विभव और विद्युत क्षेत्र की तीव्रता टॉपिक पे चर्चा करेंगे। आप हमारे अगले वीडियो लेख की प्रतीक्षा कीजिए। धन्यवाद।